Hey folks! Imagine an AI model that can detect, classify, and segment objects in a single step, without those complex pipelines you're used to. What if I told you this model uses transformers, the same tech behind GPT-4, to completely redefine object detection? Welcome to DETR, Detection Transformer, developed by Facebook AI Research, FAIR. It's setting new standards in computer vision, real-time AI and automation. And today, I'm diving deep into how DETR is revolutionizing AI vision. First, what is DETR, and why was it developed? DETR, or Detection Transformer, is an end-to-end object detection model. Unlike older models like YOLO and faster RCNN, DETR directly predicts objects using a transformer-based architecture. It eliminates complex steps like region proposal networks, RPNs, and anchor boxes, simplifying everything into a single neural network pass. So why is DETR so revolutionary? It detects, classifies, and segments objects in one step using transformers for vision, the same tech behind GPT-4 and BERT. It also removes the need for post-processing techniques like non-maximum suppression, NMS, making it simpler and faster. But why was DETR developed? Before DETR, object detection was complex and computationally expensive. Models relied on manually designed anchor boxes and multiple steps for region proposals, bounding box regressions, and classifications. DETR changed the game by eliminating these steps, making object detection more accurate with fewer parameters. Now let's break down how DETR works. First, an image is passed through a convolutional neural network, CNN, to extract features. Then, a transformer encoder-decoder processes these features and models relationships between objects. Finally, the model directly predicts bounding boxes and class labels. No need for anchors or region proposals. The result? Simpler, more accurate object detection. Let's talk real-world use cases. In autonomous driving, companies like Tesla and Waymo explored DETR-like architectures for real-time scene understanding. For security, AI-powered cameras use DETR for facial recognition and threat detection. In e-commerce, Amazon uses similar models for automated product tracking and smart checkout systems. And in medical image analysis, DETR-based AI models help doctors detect tumors and abnormalities. But DETR isn't perfect. It struggles with small objects and has a high computational cost. Plus, it needs large datasets for training. Yet despite these challenges, DETR remains a game changer. What's next? We're looking at DETR++ and improved vision transformers, faster and more efficient. AI for edge computing is being optimized for mobile devices and real-time applications. And DETR will integrate with multimodal AI for AI-driven robotics. DETR is paving the way for a new era of object detection, where AI understands images as efficiently as humans. So, would you use DETR in your AI projects? Comment below. Like and share if you believe transformers are the future of AI vision. And don't forget to subscribe. Thanks for watching, and I'll see you in the next video.